Hi, my name is Chad, and today we're going to be talking about standard work. Now, when you hear standard work, a lot of times we think, processes or procedures, and certainly there's elements to both of those inside of standard work, but really what we're looking for is a sequence within the process steps. And today we're going to cover all of that. And specifically by the end of this video, you should know the definition of standard work and why we actually need standard work, understand the three elements to include in standard work, and know how to complete the standard work combination sheet. And just a spoiler alert here, if you stick around to the end of the video, I'm going to share two important tools you can use in conjunction with the standard work combination sheet to achieve incredible results for your business or organization. All right, so let's talk about the definition of standard work. And basically, now I'm going to go over the definition, but of course I'm going to give you a summary, but standard work describes the process of documenting the steps of a work process, assigning roles and determining the ideal sequence of those steps with the goal of establishing and maintaining consistency. So if you break this down and look at this definition in pieces, well, we want to document a sequence of process steps that involves work, right? And we want to make sure we're assigning roles. Sometimes we call those operators. Certainly on the standard work combination sheet, we'll call those operators, but you assign roles to those process steps. And what you're looking for is an ideal sequence to promote consistency within the process. Now, it doesn't mean that when you first document the standard work, the process sequence of steps, you're not going to have the most perfect and ideal sequence of steps that gives you the most optimal output. That's just not going to happen, right? It's going to take some work to get to that. It's going to take something known as Kaizen. You want to keep Kaizening those process steps, the process itself, to get to that optimal output. But we'll talk about that later. So ideally, what we're trying to achieve with standard work is a process that is both efficient and effective. But what is efficient and effective? Well, efficient means the ability to accomplish something with the least amount of wasted time, money, and effort or competency in performance. So basically what we're saying here is that when you create something that's efficient, you're creating that process or you're recreating that process with less waste, right? Less waste means less time, money, all that can be considered waste. Now, the competency in performance means, okay, well, what does that mean? Well, if it basically means if we have two people, one person that is maybe relatively new to the process, that's what it means by competency. Not that they're necessarily dumb or anything like that. It has nothing to do with IQ. It just means that maybe someone's new to that process, right? And we want them to get acclimated quickly to that process, right? To that sequence of process steps. Meaning that if someone has been running that process for 5 years, that's great. They're probably very efficient at that process. But we want to create the process steps in a way that anyone going into that process can also quickly acclimate themselves to that efficient sequence of process steps, right? And so that's what it means by competency and performance. Now, when we talk about effective, that's the degree to which something is successful in producing a desired result. And this basically means that if you're, producing widgets or something, you're actually producing that widget with no defects, right? Or very few defects. You don't really want any defects. Now, you can be effective at something, but not efficient. I'll give you an example. If I were to go out to my car and change the oil, I can certainly change the oil in my car, and that means I'm effective. At the end of the process, I will have effectively changed the oil in my car. But it doesn't mean that I'm efficient, right? It means that someone that does that day in and day out would be much more efficient at that process. Not only would they be more efficient at the process because they do that process all the time, but they'll also be more efficient at the process because they have the right tools. And so we want to make sure that whenever we're creating these efficient and effective processes, that we're giving our people not just a sequence of events or a sequence of process steps that produces the most effective or efficient process step, we want to make sure we're giving them the tools as well. So when we're trying to create an efficient and effective process, we need to create a consistent process made up of an efficient set of sequence steps that delivers a product or service. Basically, what we're saying here is that we want to deliver what our customer wants when they want it and how they want it. Once we know what our customer wants, we can translate that into a number that we can use to set up the process that delivers it. And so how do we get that number? Well, we start with the demand. All right, our customer has a certain amount of parts that they want. Of course, there's other things involved, right? They want quality parts that will give us specifications, but we start with the demand. They want some number of pieces, some number of something from us. And then we can determine the takt. Now, takt just is a German word for metronome. It represents the heartbeat of a process. You think tick, right? That's the takt of a process. And the way we get that number is through a simple formula known as time available divided by demand. And that's what this represents here. Time, that's what the T stands for. Time available divided by demand, right? And that's our customer demand. And that's a simple formula for TACT. So let's take a look at how we calculate that. So if we look at this simple chart here, before we do that, I want to just say one thing. Whenever you're calculating TACT or you're trying to figure out what your time available is, then you want to make sure you're using the same unit of measure. And that can be minutes, hours, or seconds. For example, when I worked in aerospace, we had long cycle times, 36-hour cycle times. So it wouldn't make sense to put that into seconds. But I also worked in automotive. And in automotive, we had 17-second cycle times. So that's, seconds would be applicable there. The point I'm making is that whatever your business is, make sure that the time available is in the units that make sense for your business. Now, with what I'm set up for here, I'm just using minutes as an example to make it simple. And so first we start with this big blue bar here. That's 480 minutes. And that represents 1 8-hour shift. So if you just take 8 times 60, that's 480 minutes. Work time per day. Now, for the sake of simplicity, I'm just using a, one shift, 1 day, and I'm not, doing a 3-shift operation here, right? Because you can just multiply it to get to the 3-shift operation, but I just want to keep it simple here for you. So let's suppose we have the 480 minutes, and then we remove breaks and lunches. We do not want to include those planned things that we're going to be down for, those planned times we're going to be away from the work. We don't want to include those in the time available, right? So we take the 60 minutes out for lunch and then the 2 30-minute breaks. And what we have is 360 minutes of time available per day to make whatever our customer needs. Now, it's also important to note that you may have other things that you remove in this time. You might have scheduled meetings, right? Scheduled downtime. Make sure you take that out as well, because that's going to impact your time available, and it's also going to impact your overall TACT time. So let's calculate that really quickly. Suppose we have that, we're working 1 shift per day, 5 days per week, and the customer demand is 500 units per week. We'll just take 500 divided by 5 days per week, and that equals 100 units per day. We take 360 minutes, our available time, divided by the 100 units per day, and we get 3.6 minutes. And that just means that every 3.6 minutes, a part must be produced to meet demand. And that is our TACT. Things to consider: shifts per day, additional time like scheduled meetings, which I've talked about, and then working days. Are you on a 5-day schedule, 7-day schedule, 6-day schedule, that kind of thing. So just some things to keep in mind as you're calculating that time availability, really to get that TACT time. And so now that we know our TACT is 3.6 minutes, we can look at the sequence in our process, right, to determine if we can achieve what our customer needs. And we're going to take a look at that in a moment. And we can use the standard work combination sheet to accomplish this. But in order to do that, we need 3 elements. We need our TACT time, we need our cycle time, and then we need the sequence, the process sequence, right? The steps in sequence. All right, so this is a standard work combination table, or the standard work combination sheet. It's the same thing. At the top here, we have all the information that we would put, like the date, the process, and all that jazz. I have already documented the TACT time, which is represented by the 180 seconds, plus I've documented that as a red line here on the graph. But what I really want to draw your attention to at the moment is the far left here. All of this information where we're on the left side of the screen. So there's a couple of things. One, we have the sequence of steps, basically just numbering out those 1, 2, 3, 4, 5, and so on. And then we have the work content, and that just means like what's happening when, what am I measuring here? And for this example, I pulled this straight out of the Kaizen Masterclass, the Kaizen Pro System, and I have this over on my website, learnkaizen.com. If you're interested in learning anything about Kaizen, root cause analysis, or lean, you might want to go check out any of those classes I have over there. You get this form. I show you how to fill out this form. I show you how to use this form to actually improve processes through Kaizen. Again, that's learnkaizen.com. I'll put a link down in the description below if you want to check that out. But this is, I use an example in that course on how to make toast. And why do I do that? Because everybody's made toast. And when you teach stuff like this, you want to make sure you're contextualizing the learning, right? You want to show how to use a tool and apply that tool to something we do every day. And then by doing that, people learn faster because they go, hey, I know how to make toast. Wow, I didn't know I could use these tools from Lean on how to make the process of making toast better. Now, what that also does is it teaches them, hey, if I can use it to improve making toast, now I can contextualize and see how I can use this in my everyday work that I do, right? All right, because we all make toast, but we all have different professions. Anyway, that's why I use that example. It's a very famous video on YouTube that is famous in the lean world of making toast. A lot of people have tried to replicate it, but nonetheless, that's what we're measuring here. That's why it says get bread, get plate, remove bread. And then we have some time over here in seconds. We have manual time, machine time, and walking time. Now, at this point in the course, I have not documented the machine time or the walking time. I do have it in here, like I show it, so I don't want to throw you off, but you get the layout of the sheet nonetheless. Now, on the far right here, where you have these smaller blocks, this is like the time, right? The time-based Gantt chart that we would use to visually represent or illustrate each step as in time. So for example, you have your time ladder at the top here in seconds, and then you can say like get bread, right? And it's 11 seconds. Then you can see we run to about 11 seconds, right? And it's not exact, but it's close enough, and it gives you an indication of how this sheet looks. And so then what we do is we basically plot each one of those out in the order of sequence that they're actually done in, the steps are done in, and it lays this out like a Gantt chart, right? Now, one note I want to say is that you can also add operator over here with the sequence, right? You can add another column. This happens all the time, and you add operator. And that's very useful when you're trying to figure out how many operators you need, or if you can move steps around through, you might want to add more steps to one operator and less steps on another. You really get to see the workload each operator is put under. And that's why it's important to sometimes have the operator over on the side. Now, for the example I use in the course, we only have one operator, so I don't have that. Next week, I'm going to show you a video. I have it down here about the operator loading chart in the Yamazumi, and I'll break this down for you and show you why that's important for the operator. So don't miss next week's video. But for now, let's just keep processing through this standard work combination table and how we can use this to improve our processes. So if we follow this along and say, great, we got 11 minutes, get bread, put bread away, all the way down to load toaster and start toaster oven. And I specifically want to draw your attention to this because we have some manual time, right? We have a few seconds, it's like 9 seconds or so, if I can see that, it's kind of small. But we add that here as manual, a manual operation. But then we have all this sort of machine time that's happening, right? And we know it's machine time because we have our legend down here where we have time as a solid block, machine as the dotted black line, tack time as the red line, and then we have waiting as the dotted red line. So this is all machine time. And why is this important? Why am I drawing your attention to this? Well, it's because it's exceeding our tack time, right? We've documented our tack time, and we're just kind of running over that tack time right there. And anything that's beyond this is too long for us to meet our customer demand. We know we've already calculated our customer demand. We know that formula. We know that we have to meet 180 seconds in order to meet our customer demand. And because of this long machine time, i.e. the toaster oven is running, we can see that we are way over tacked, right? And I also want to show you a couple of important things that, is good, but it's still not helping the process. And that is something we call simultaneous activities. That is when we run the machine, like we hit the go button, the toaster's in the toaster oven, we go and we get the butter knife and we get the butter, right? Which is great, right? We go and get the butter and the butter knife, and now we're still waiting, right? All this time is waiting for the toaster oven to finish. So some way, somehow, we've got to Kaizen this process to get all of this time way back here in the process. Now, I'm not going to go over and show you how we do that here. I'll show you that in the course, but there's ways to Kaizen this. And, maybe you have some ideas, I don't know, but the point of this sheet in this video is to show you the standard work combination table and how we use this to illustrate what's happening in the process. And here we can see we're not going to make tack time if we don't do something, if we don't Kaizen the process, if we don't make this process better. And listen, I've used these standard work combination sheets my entire career, right? This is not something that's new. It's been around for a while. Very powerful tools if you know how to use these, and certainly you probably have a better understanding of how to use these now. But you use these in conjunction with the Yamazumi, the operator loading chart, which we'll go over next week, and then the cell layout, right? And if you do all of these in conjunction, you can have yourself a nice little pack of the process, and you can use that to improve the process, to Kaizen the process, right? Just like we're kind of showing here, we need to do a Kaizen in order to get our time under tack. So make sure you come back next Sunday and watch the operator loading chart video along with the Yamazumi, because it's going to make a lot of sense. But hopefully you've gotten a lot of value out of this video. So before we wrap things up, I also want to talk about WIP. Standard WIP is also important and cannot be overlooked. We want to ensure our process is continuously operating, and standard WIP helps ensure that, right? It helps ensure we mitigate process inefficiencies, right? But we should always work to reduce the WIP. WIP costs money, but when you have a process that's inefficient, you want to have a strategy, right? A whip strategy, and say, listen, I know I'm going to have to load this process up right now with some standard whip because my process is inefficient. But I also know that I've got plans to Kaizen this process so I can work down the waste and work down that inventory. And once we have the standard work combination sheet, the Yamazumi, the operator loading chart, and the cell layout, we have our standard work for that process, and we can use that information, the sheets and all the data, to make the process better, to Kaizen the process, right? Thereby making the process more efficient and effective. Again, don't forget to check out my website, learnkaizen.com. And when you're over there, there's a free Kaizen blueprint I want to give you. It gives you like an agenda. It lays out the process for facilitating your own Kaizen. Make sure you grab that Kaizen blueprint. Tune in next week for that Yamazumi and operator loading chart. I'll see you then.